All right, welcome to semester 2. So this is our review for the first summative in Algebra 2 for 2019, January, specifically 2019. Just like last semester, I'm going to do all the A problems, and then we're going to leave the B's for you to practice on your own, but we'll post the answer key to everything, of course. So here, for this first section, we're going to be using regular polynomial function, not function notation, just polynomials, and we're going to be doing different operations, adding, subtracting, and multiplying, and then we're going to create profit functions. So this first question, they just want you to add all your like terms together, so just carefully choose the like terms, and I would love if your answers are in standard form. That makes my grading really easy. So I noticed there's only 1x to the third term, 7x to the third power, and then I look for the next term in line, which would be the x squared term. So you have negative 9x squared, and then remember you're adding positive 9x squared. So that's a case where, hello pen, come back. That's a case where the 9x squared and negative 9x squared will actually cancel each other out. And then next in line for standard form would be plus 4x, and then plus a negative 18x. So 4 plus negative 18 is negative 14x. And then lastly, we have the constants. So we have negative 12 plus 7, better known as negative 5. So answers in standard form are always my favorite. Technically, you can have any order. Just watch your signs. All right, this next one is the one I'm worried about. This time you are subtracting. So make sure you're recognizing that you have a subtraction sign right there. I think it would be brilliant if you went ahead and you distributed the subtraction sign to everything in the second polynomial. And that way you can change everybody's sign appropriately, and then you can just collect like terms. Because you guys are really good at collecting like terms. Sometimes you get a little off task when you have to distribute a negative in your head. So right here, this becomes a, I'm going to change color here, we have a negative 7x squared, and then that'll become a plus 3x, and that'll become a minus 5. So now when I go to collect my like terms, I'm going to start with the x squareds, because that would be standard form, first term. So you have 8x squared, and then we have minus 9x, now it's a plus 3x, so that's a minus 6x, and then constants, you have a plus 8, and now this is a minus 5, so you have a plus 3. So again, standard form answers are my favorite. Technically any order works, just watch your signs. Alright, multiplying. Be careful on 3a. It looks really unassuming, like it's not going to give anybody trouble. You just have to remember what it means to square a binomial. You can't just distribute a square. What this means is you have 2x minus 3 times another 2x minus 3. Yes, it is a distribution question though. 2x times 2x is 4x squared. And then we have negative 6x. And then another negative 6x, which I'm kind of hoping you guys are comfortable adding that in your head without writing it down separately, but if not, that's okay. And then we have negative 3 times negative 3, which is positive 9. So final answer would be when you do indeed add those together. So you have 4x squared minus 12x plus 9. That would be this question right here. All right, so here, this next one. This one takes a little bit of work. We do have to distribute. We just have some larger polynomial here. So the x gets distributed to everybody in the second polynomial. So we have x to the third plus x squared plus 7x. And then we're going to distribute the positive 4 to everybody in that second polynomial. But instead of continuing to write a gigantic line of work, I'm going to write them underneath their like terms. So plus 4x squared, I'm going to write right here, underneath the other x squared, plus 4x, right there, and then plus 28 doesn't have a like term, so just smush it over there. Now everything's lined up beautifully, look at that. Except I drew over my signs, that was stupid. Alright, so we have x to the third, those are all positives I believe, so plus 5x squared, those are all positives, plus 11x, and plus 28. Answer in standard form, because we made it that way. Alright, so that's one more question. Profit function, the most important question. So the price per mug is referring to what's called a revenue equation. Revenue is money that you're taking from the customer. So this is the revenue equation, or function. And remember, revenue is money that you're gaining because you're taking it from the customer. So when it says the price of one mug, you should be able to look in your function right here and tell that we're charging $13. But that's not actually the money you're going to make in profit, because profit is found by taking the revenue, but then you have to subtract cost. Oops, wrong color, Abruzzo. That's not an eraser. Holy cow. All right, revenue minus cost. So this is the part where I'm going to put cost, the word cost, or the abbreviation if you're using one, in parentheses, because that's the part where kids mess up. So reading along here in our function for cost, it's right there. Cost means you have to pay out to create the product, so that's a subtraction for us. That's why we're subtracting it. So our profit function would be, and I love to call it P of x for function notation, the revenue function, which is 13x, but then you're going to subtract, and again, parentheses, super important here, the cost function, 6.25x plus 400. All right, so here, crucial step. Y'all knew to subtract the 6.25. Just make sure you're also realizing you're subtracting the 400. And of course, I don't have any more room. So I'm going to, my works can come up here. So the profit function simplifies to, let's see, what does it come out to? 6.75x minus 400. Okay, there's profit function. 6.75 showed up when we did 13x minus 6.25x. All right, so now you're going to use that profit function, and you're going to figure out the profit if you make and sell 2,000 coffee mugs. So plug in x equals 2,000 into your profit function right there. And when I did this, I got 13,100. That's not 100. Okay. One more time. There we go. 13,100. There we go. Okay. So there's going to be a set of questions just like that. You'll get a score. For our new friends from Algebra 2 who haven't had me before, you're getting a score of 1 through 5. 5 meaning you're perfect. 4 meaning you know what you're doing, but you're making some small mistakes. A 3 means you have one concept mistake. And then a 2 means you have multiple concept mistakes. We won't talk about a 1. We don't want a 1. All right, number 6. This is going to be a graphing calculator question eventually. If you don't have a graphing calculator, remember that you can use an emulator on a computer or a phone. For the Android, a really good one to use is called WabbitEmu. That's specifically to Android. I don't know what iPhones have. I know you have to pay a few dollars for the iPhone version of this. The Android one is free. So, anywho, before we get to that section, we have some vocab. So this polynomial is in standard form. That's nice. And then it says, what is your lead coefficient? So lead coefficient is the number in front of your first term when in standard form. So your lead coefficient is -3. The degree is the highest exponent that you see in the problem. So once you're in standard form, the degree is really easy to pick out. It's at 4. And then remember that big ugly chart on your notes that talks about type. So your options are constant, linear, quadratic, cubic, quartic, quintic. A degree 4 is referred to as a quartic. So please attempt to spell these properly, because quartic and quadratic do look kind of similar. So little note to yourself to look at the chart. The one on your test, it'll be one of the major functions. So like quadratic, cubic, quartic is probably your only option. So as long as you know those 3, you're good. And then here they want you to plug in a 2. So if you plug in x equals 2, that really cool thing you could do is that store function. Remember, you can do 2, and then you could store it as x. And then you type the polynomial in your home screen. But the other thing I might suggest you do, since we're going to be typing this in our calculator in a second, you can also use your table or even your graph. So this function, now we need to go to our calculator and type it into y equals, which I've already done. So that question where it said plug in x equals 2, remember how your table automatically figures out stuff for you? Well, kaboom, right there, look, x equals 2. It gives you, oh, but that's not what I got the first time. All right, timeout. Oh, I'm super glad that I looked at this, because when I did this key by hand, I didn't use my calculator. because I was trying to be cool like that. I got the wrong answer because I had negative 3x to the second on my paper, not to the fourth. So I'm glad we did this. So I'm going to catch my mistake. When you plug in x equals 2, or yeah, 2, yeah, oops, you should get negative 27. Now, I'm looking at the graph right now, but let me back up a second. I want to show you guys or remind you what it looks like to store. So remember you type, for Pete's sake, not that. You type the number first, 2, and then stow, and then x. So if you were just doing an evaluation question and you wanted to store, you could just type it like this. So then you type the function negative 3x to the fourth. Obviously you wouldn't do this problem more than once, guys. It's not like I want you to do it multiple ways. You just kind of have to figure out what's easier for you. I like the store feature. Some of you were very excited to hear about the store feature. It's a way to make your calculator plug in numbers for variables, so that's kind of cool. Anyways, go back to your graph. They're going to want you to sketch this. Now the first problem I'm seeing is this sketch is, this window is not appropriate for this curve. I need to raise it up a little bit higher. So I'm going to go to Window, and to raise your window higher, that means your range has to be higher. That's your Y max. So I'm going to go to like 25 just to be safe. Probably too high, but that's okay. There we go. So really weird looking, like no symmetry, like it's just weird. There are arrows at the bottom of this curve, and I kind of know that because a quartic is a cousin of a parabola, but remember this quartic has a negative coefficient of negative 3, so it's going to be reflected or upside down, as you guys used to call that. So sketch that on your paper, and the domain question should be very, very easy for us. So I don't remember what it looks like exactly, but something like this. Not exactly like that, Abruzzo. That's a terrible drawing. All right, the domain is an easy one. Domain for polynomials is always negative infinity to infinity. The range, remember, is low to high. So they're asking where your y's begin, it's not an A, and end, but you have to do it in that order, right? From low to high. So the range starts down at negative infinity. But I guess the question is, where does it stop? And for that, we need to go back to our calculator. And we have to find whatever this top y value is. I could estimate it right now, but that's not going to be good enough for my teacher. So I'm going to go and find the maximum, because that would be the top of the function. And then it's asking you to submit x values that are to the left and then eventually to the right. So I can tell it's approximately at x equals 1. So x equals 0 is definitely to the left of that, so I'm going to hit enter. And then I need to either scroll so that I'm to the right of the maximum, or I could hop. I'm going to hop over to x equals 2. Remember, I have a delay. And then there's 2 blue lines here. It says, is your max in the middle of those? And I go, yeah, by hitting enter. All right, so this ordered pair, which I'm going to go back to my slide for this. Oops, remember what the ordered pair is, Abruzzo. It is, let's say, we can round to the tens place. I'm okay with that. So 0.8, 12.6. So this guy right here is 0.8, 12.6. So the range, remember, is y value. So the top y value there is 12.6-ish. And because it's a point, not an infinity, I'd like you to use a bracket on that one. Okay, and then one of our new concepts here, end behavior. It looks real scary. I'm going to go ahead, oops, I didn't write this down, this was negative 27. I'm going to go ahead and give you the template this first time, totally filled out except for these blanks. So you just have to kind of translate what this means. It says, what does the function do as x goes to negative infinity? Well, that's a really fancy way of saying left. So on the left side of your curve, your function's going down. The way we say down is negative infinity. And then over here, as x goes to positive infinity, is a very fancy way of us asking for the right end behavior. So on the right side of your function, it's also going down, so negative infinity. Your only options for these 2 blanks when you're filling them out are either up or down. So you just have to look at the graph to figure that out. So you're going to get to do that one on your own. Oh, everyone's favorite, factoring. Now, if you have your factoring flowchart from last semester still, you can use it. Otherwise, I will project one on the board. But remember, we're looking for first any common factors. That's important to look for, especially on this test. And then once you realize if you have a common factor or not and whether you've taken it out, then you have to decide whether you're looking at 2 terms or 3 terms. And obviously our approach is different after that. So, this question, no common factor. And I have 3 terms, so we're just going to use that reverse foiling process for factoring. So my first terms are supposed to multiply together to give me x squared, so that would be x and x. And my last terms are supposed to multiply together to give me negative 22. So that would be 1 positive, 1 negative, and 22 is 11 and 2, amongst other, there's 22 and 1 as well. But I'm going to use the positive 11 and the negative 2, and because I'm a creature of habit, and this is a good one, I'm going to always check my arches, especially on a test. I can't afford to have a silly mistake on this section. You guys are too good at factoring. Alright, so if you add those 2 green arches together, you do get 9x in the middle. Perfect. Alright, going over to 8a. There is no common factor. So I move down the list. It is 2 terms long, and since it is 2 terms long, it must have that special factoring pattern of the difference of 2 squares. So this is that factoring pattern where you look at the first term, and you look at the last term, and you realize that they're both perfect squares. So then you take the square root of each term. So the square root of 49x squared is 7x. And then the square root of 16 is a 4. And the way the pattern works is one sign is a plus and one sign is a minus. You still want to check the arches though. Some of you kind of forgot this step on this pattern. Negative 28x and 28x, notice how they add up to nothing, which I will notice there is nothing in the middle. So good job on us. Alright, moving on. Number 9a. So back to the top of the flowchart, it says always look for common factors. This is a great problem for that because look, you have a common factor. You have a common factor of 3 that you're going to factor out of the trinomial. And when you factor out of 3, you still have an x squared, and then a plus 8x, and then a plus 7. Now the 3 is going to stay in front, but you're going to use your traditional reverse foiling kind of factoring on this remaining problem. So what times what gives you x squared? That's x and x. And then 2 things at the end that multiply together to give you 7. And then as I'm thinking ahead, I want my arches to add up to 8. So that's an easy puzzle for us, isn't it? Plus 7 and plus 1. I still want to encourage you to check the arches. The important part about that question is that you thought to take out the 3 at the beginning of the problem, and then that 3 stays with the problem. It's not gone at any point. It's still here. Alright, number 10. Bummer. There is no common factor. Which, take a deep breath, because that means this is going to be one of those you got to guess and check questions. But the process is the same. So the first terms, oh thank goodness it's prime. There's only one way to get 7x squared, 7x and x. At the end of the problem, however, if I have to multiply to give a negative 8, the signs have to be the same, so either plus plus or minus minus, and as I look ahead in the problem I notice they're going to add up to negative, so I'm going to go ahead and put down 2 negative signs, just to get that out of the way. 8 has a couple options. 8 could be 4 and 2, 8 could be 8 and 1. So we usually pick the ones that are closer together, and I'm just going to throw down 4 and 2, and then we're going to see if it works out, because I'm going to check the arches. So this outside arch is negative 14, I wrote too big. This inside arch is negative 4, negative 14, and negative 4, yes, does add up to negative 18. So we really, I mean, a little educated guessing, but we lucked out. Our guess on the first one worked beautifully, so yay for us. Alright, number 11a is the most challenging question. There's no common factor, and then to make things even more fun, the first term, man, it's got options. So it could be 5x and 2x, could be 10x and 1x. So we have to keep those options open, don't we? And at the end here, my factors have to, the back factors have to multiply to 4. So it could be 2 and 2, could be 4 and 1. So we have options all around, and the key to the puzzle is to check your arches. So a little educated guessing, not always, surefire, but educated. Our teachers usually tell us to pick the numbers that are closer together, especially if that middle number is not really big. So 5x and 2x, I'm going to start there. Now, because of our experience with factoring, if it's 5 and 2, then that means you can't have 2 and 2. Because if you put a 2 right here, you'll have a common 2. And we already said there's no common term. So I'm going to ignore the 2 and 2 option for now, and I'm going to try 4 and 1. Now for that same reason, I'm not going to bother to put a 4 here, because 2 and 4 would also have a common factor. So forget that. I'm going to put a 4 here, and a 1 here. And I haven't messed with my signs yet, but I recognize that if I have to multiply to a positive 4, that means I either need a plus plus or a minus minus. And looking in the middle of the problem in the puzzle, I need minus minus. Alright, let's check these arches. Oh man, guys, we are wonderful guessers today. Look at this. Negative 5x and a negative 8x. Those do add up to negative 13x in the middle. Awesome. So a little perseverance, a little educated guessing on our part, and we're going to get those right. Alright, new stuff. Get a new score for this section. This is power function operations. So a lot like the beginning of the test, but everything's going to be in function notation. 12a, they want you to add the functions together, but not just the functions. They want you to add the functions with x equals 4 plugged in. So what I would do is I would go to my first function, and I would plug in a 4. And you can do this however you want. You could use that store feature on your calculator. You could just manually plug them, oops, not 2. You could plug them in, manually in the home screen with parentheses like I'm writing here. Or you could mentally plug in a 4. That's always scary on a test, though. So this, I think I did mine mentally, so that makes me a little nervous. Let's see if I got it right. I got 15. All right, I think this is a 15. But now I got to do the same thing with the g function. So that was f. Now we're going to do the same thing with g, which is this guy. So plugging in a 4. That was a little easier to plug in. You get a 47. And then remember how they wanted you to add these together? Well, go ahead and add them together. So you got 15 plus 47, better known as 62. So a couple of different ways you can do that question as far as plugging in or evaluating it for. Some kids actually like to plug the functions together, like add them together. And then plug in x equals 4 into the result, and that's fine. There's no right or wrong way to do the question, and frankly they're both just as time consuming, so I don't care what you do. 13a, however, I'm a little nervous about this one, just because I'm always nervous about subtraction of functions because of the distribution. So I'm going to write f of x first, which is 2x squared minus 3x minus 5, and then we need to subtract, and then I get really nervous here, so I'm going to go ahead and put parentheses, the g function, which is 10x plus 7. So because we're subtracting the function, and I used parentheses, I'm going to remember to subtract both parts of that green function. In fact, I might just rewrite it. 2x squared minus 3x minus 5. This is now a minus 10x minus 7. Alright, now collect your like terms, please. There's only one x squared term. And then we've got a couple of x's here. If you add those together, negative 3 plus negative 10 is negative 13x. And then our constants here at the end. Negative 5, negative 7 is negative 12. All right. So 13b is very similar to 13a. I want you to practice that one on your own, please, and check the key. Same thing with 12b. All right, same functions. This time on 14a, we want you to multiply those functions together, but we also want you to plug in 3. So you could multiply the functions themselves together and distribute and collect like terms and then plug in a 3 at the end. I don't know if that's the easiest way to do this question. I think it would be easier if you just plug in a 3 to each function separately. So again, on your home screen, you could use that store thing. You could do it mentally, but I don't know if that's a good idea on a test. I think this comes out to a 4, but again, I did mine mentally, so that's scary. And then other function, g, plugging in a 3 there, that was a little easier. It gives you a 37. And then remember they want you to multiply these together. So I'm going to take the 4, I'm going to take the 37, and we're going to multiply them together. Which is 148, I think. Cool. 14b is similar. Try that one. Make sure if you're doing this on your home screen that you're using parentheses around a -1 for x, because if you don't use them properly, you're going to get the wrong sign on that first function. All right, 15a, they want you to divide, which that's actually a really easy question. They want you to take function f and write it in the numerator. I'm going to work down here. So 2x squared minus 3x minus 5. And then they want you to divide it by function g, which is 10x plus 7. That's actually the answer to the division question. You're just setting it up. So this is the answer that goes right here. And then the domain, this is the problem. So when you have a fraction, remember we cannot divide by a 0. My pen is going crazy. All right, so what you're going to do to find domain is you take your denominator, the bottom of the fraction, and you tell me that it cannot equal 0, and then you solve it. So 10x plus 7 cannot equal 0, and if I were to solve that, I would subtract the 7 over, and then I would divide by 10. So x cannot be negative 7/10. That's what you write down for a domain right here. I don't know why I'm writing so backwards and crooked. Let's try this again. X cannot be negative 7/10. There we go. That's the domain. This is the function itself. Kind of crazy, huh? All right. I feel like I skipped a question, though. Oops. There's a whole question after this. Where'd it go? All right, I'll just write it down. 16. So question number 16 is a composition question, and it's f of g of negative 2. So when you compose a function into a function, add a number. What you do is you start on the inside of that composition question. So you start by finding g of negative 2. So remember, function g was 10x plus 7, I believe. So 10 times negative 2 plus 7. And if you compute that on your calculator or in your brain, oh man, I did it wrong. For Pete's sake. Alright, so that's, I don't even have a calculator. I'll have to pull up my other one. Alright, so this is negative 20. I plugged in a 2, not a negative 2. Darn it. Okay, so this is a negative 20 plus 7, which is negative 13. So now what you're going to do is you're going to come back up here. You're going to say, forget this g of negative 2 business. We're going to plug in a negative 13 right here now. So step 2, so this is your first step. Your second step is to now take function f. I think I just said the wrong thing. I apologize. We're going to plug in a negative 13 into function f, which I'm going to have to redo because I didn't do it. Function f, what was it? It was 2 times x squared minus 3 times x minus 5. So we're plugging in that negative 13 here and here. And I'm going to go here. And you know what I think I'm going to do? I'm going to use that store feature. Seems like a good idea. That way I don't have to worry about parentheses. So I'm going to take negative 13, store it as x. Stow. And then I'm going to type the function in the home screen. And I forgot what it was. It was 2x squared minus 3x. And then minus 5. So apparently the answer is 372. Which is a far cry from my answer, because I screwed this up. Ironically, I got 1,372. I don't know how that worked out. Alright, so the answer we just got, 372. That's your answer to the question. This is it. I know it feels like a year and a half later we got an answer. So this is all the process to get the answer, but this last number you get is the actual answer. Man, I'm really hoping I didn't mess that problem up. If I did, I apologize. Okay. Good luck to everybody. This is our first summative. It's going to be your entire grade for a while here, but you are getting some good quality scores, and we are going to move on in factoring. So make sure that you're getting a really good score in that factoring section. Otherwise, we have some tutoring in our lives, right? We need to come in for help on the factoring in particular, because we're going to move on to harder factoring next. All right, good luck, everybody.